Hi everyone, this is lesson 4.4, standard form. In this lesson, you're going to learn how to write linear equations in standard form and how to convert from point-slope form to standard form, and also how to write equivalent equations in standard form. And then in the next lesson for part 2, you're also going to look at some word problems and finding missing coefficients like a, b, and c, figuring out what the a, b, and c are in the equation. So that's for the next video though. So in this video, we're going to warm up by just writing what the standard form of a line is, and then you're going to identify the forms of these three equations. So standard form of a line is ax plus by equals c. Now there are two very important things to note here. So if you were doing the extra credit, this is on the back page of the extra credit. And the first thing to note is that a, b, and c cannot be fractions or decimals. Cannot be fractions or decimals. So that means that they have to be integers, so positive or negative whole numbers. However, the leading coefficient, which is a, has to be positive. So a must be positive. And if it's not, we're going to learn that we can multiply it by just -1. We can multiply the whole equation by -1 in order to make it positive. Or in another video, you learned how if one of these a, b, or c was a fraction, you would multiply the whole thing by the denominator of that fraction to clear the fractions. So you probably have looked at 1 through 3 already. And if not, so go ahead and take a second to figure out what kind of forms of the equation these are. All right, so number 1 would be standard, because you got ax plus by equals c. Now, one thing you might want to notice is that, so in number 2, that would be slope-intercept, because it tells you what the slope is and the y-intercept. And slope-intercept is y equals mx plus b. Now, one thing to note is that the b here is different from the b up here in standard form. Those are two different b's which represent different things. Also, what some people get confused on is that a and b are not the x and y intercepts. The x and y intercepts are found by dividing c by b or by a. And if you don't know what c is, then you can't figure out what a and b are. Anyways, and then number 3 would be point slope, because it gives you the 0.6, -4, because it's the opposite sign, and then the slope of 2. All right, so let's look at some examples here of equivalent equations. This is to write two equations in standard form that are equivalent to the given equation. So in order to make an equivalent equation, all you need to do is multiply the whole equation by something. And it can be anything, anything except for 1, okay, because that's cheating. So it could be -1, it could be -2, it could be +2, it could be a fraction, it can be 1,000, okay, whatever you want. In this case, I'm going to give you a couple to work with. In this case, what could we multiply here? We can multiply by -2. Let's try doing that. Well, we shouldn't really multiply by -2 because we don't want the a to be negative. So let's just multiply by regular 2. So if we multiply this whole equation by regular 2, it would become 4x minus 12y equals 8. All right, so write that example down. I'm going to clear that example because I want you to think of a different number, perhaps a fraction you could multiply this equation by in order to still have your a, b, and c be integers. So what fraction could you multiply so that a, b, and c are still integers? So for example, we couldn't multiply it by 1/3 because 2 and 4 aren't divisible by 3. We couldn't multiply it by a fourth because 2 and 6 wouldn't be divisible by 4. But what about 1/2? We multiplied, since 2, 6, and 4 are all divisible by 2, we can multiply it by half. So this would become just x minus 3y equals 2. So that would be one equation, and then the other equation, I guess we could compare it, would be 4x minus 12y equals 8. So then the questions you might see about equivalent equations would be like given maybe 4 different equations, which ones are equivalent to the original. So you would think, okay, what would you have to multiply? And you'd have to multiply it by everything. So even if like one of the terms isn't multiplied by a half, then that would not be equivalent. All right. Part B. So what could we multiply here? Let's do, how about 7? Let's pick 7. So 7x minus 7y equals 21. All right. Let's do another example. So in part C, so one thing you might want to do in part C, since the leading coefficient is negative, is multiply everything by -1. So if you did that, you'd get regular x minus 2y equals -9. Right, so that would be equivalent. And then part D, well, first of all, you've got a negative leading coefficient. And then another thing you can think of is that, well, these coefficients could be simplified. So what fraction could you multiply by to simplify the coefficients? So you could multiply by -1/3. So if we did that, we would get the negatives cancel out, and 1/3 times 9 is 3x. And this would be plus 1/3 times 12 is 4y. And then 1/3 times 6 would be -2, since there's only one negative for that one. All right, and then I want to show you a trick, actually. So we're going to take these two equations. Here's another little cheat method that you can use. And I know I said cheating, but it's not cheating if you are using a resource that you're allowed to use, which is Desmos. So open up desmos.com and click on the graphing calculator. And I want you to type in the original equation, so -9x minus 12y. I don't know if you can make like a split screen in your Chromebook so that you can still be watching the video. But anyways, and then go ahead and do the equivalent one, 3x plus 4y equals -2. So did you see how after we typed in that final equation, the blue line actually overlaps with the red line. So that means that they're equivalent. All right, if you, for example, let's say you messed up and you put +2, then those wouldn't be equivalent because it was supposed to be a -2. So you know that you did something wrong. All right, so, or if you just put 6, then that would be wrong. So that's one way you can figure out if they are equivalent. Also, one thing to note that on your AIR test, when you take the AIR test in April, they give you the Desmos graphing calculator. So that's something that you will, you're going to start learning how to use more of so that you can prepare for that test. All right, so let's get to some more examples. And I promise we just have 3 more examples here. So, and they're the same type. So now we're just going to write the equation from the graph in standard form. So if you want it to be in standard form, and I'm trying to find a way in Edulastic so that it doesn't mark it correct no matter what form you put it in, because sometimes it'll mark it right even if you put it in like slope-intercept form. But I think I discovered the button that lets me make it graded in standard form. So you're going to have to learn it. All right, so what you would want to do here is option 1, you can put it into y equals mx plus b. All right, the b is not on the graph, and sometimes you're given 2 points and you don't know the y-intercept. So option 2 is to put it in point slope form, which I personally think is a lot easier as long as you know the form, and since it's always open note, and if you're in class then this equation is on that poster in the room, then this is not hard to remember. Okay, so here, first you would just need to find the slope. So between these 2 points, you can use the slope formula, or you can go down 1, 2, 3 over 1. So -3 over 1, your slope is -3. And then you can choose any of these 2 points. It doesn't matter which point you choose, it should work out the same. So plug one of the points into your point slope form. So we'll do y minus 1 equals -3 times x minus 1. And then you are going to kind of like convert it to slope intercept and then convert it to standard. Okay, so the first step you would want to do is distribute the -3. So y minus 1 equals -3x plus 3. And then add over the 1 to 3. So you get y equals -3x plus 4. And then add the 3x over so that the x and y are on the same side. So then you get 3x plus y equals 4. Now, since our final equation does not have any fractions and the leading coefficient is positive, then this is good. There's nothing else that we need to do to our equation then. All right, let's try this next one. So here we're writing the equation still in standard form that goes through these 2 points. So the first thing you'd want to do is to find the slope. So when in doubt, well, some people say when in doubt, figure it out, but I say when in doubt, find the slope. You're given 2 points. So let's do -3 plus 1, and then 2 minus 3. Now careful with your negatives. This would be -2 over -1, which reduces to +2. So your slope is 2. I'm going to choose this as my point. So we'll do y minus the y, which is -1. So y plus 1 is 2 times x minus 3. And then convert that to standard form. So we'll distribute the 2, subtract the 1, and this would turn out to be -7. And then we'll have to subtract the 2x over. So it'll be -2x plus y equals -7. Is this our final answer? No, because I see a negative here as our leading coefficient. So we're going to have to multiply everything by -1, which means just flip the signs. So it'll be 2x minus y equals +7. Okay, makes sense? Great. Number 3. You're going to try this one. So go ahead and take a moment to do it. Okay, so here you should have gotten -2 for the slope. So we'll do, and I like to go backwards sometimes if it means, well, I guess our slope will be negative anyway. So, okay, let's just do -2 minus 2 is -4. 4 minus 2 is 2. So -2. I'm going to choose this as my point. So we'll do y minus 2 equals -2 times x minus 2. Lots of 2's here. Distribute the -2. This is where you may have made a mistake. -2x plus 4. Add over the 2 plus 2. And you get y equals -2x plus 6. Add over the 2x and you get 2x plus y equals 6. There's nothing else that you need to do to that equation. However, the answer choice was an equivalent equation. So if you were to multiply everything by 3, you would get 6x plus 3y equals 18. So you might have been wondering, why isn't the equation here? Because it's the equivalent equation, all right? So that is all the examples for today. So you learned how to write equivalent equations and how to write the equation in standard form by starting with point slope form. So that is all for this lesson, and I hope you have a great day.